Good morning and welcome to the 2020 virtual trade show from HM Royal Incorporated. My name is Justin Flug and I'm the technical manager for all things rubber and elastomer bonding at HMR Inc. Today's presentation will focus on OneCoat bonding and problems with traditional primer systems. First, we'll talk about the objectives of the presentation. The first objective is to introduce you to HM Royal, to what we offer, to who we are, to what we stand for. If you are familiar with HM Royal, this will just be a reminder on who our supplier partners are and who our customers are and the types of applications that we work with. We'll dive into OneCoat bonding versus TwoCoat bonding and some key differences in application and processing. We'll talk about the limitations of some of the common primer technologies that are widely used today. We'll talk specifically with data to back up our conversation regarding performance of DuPont OneCoat systems. And then we'll summarize our findings and then go through some brief product offerings. So first, who is HM Royal? We are a third generation family owned company with 95 years in rubber, plastics, adhesives, and more. We have a focused technical sales team representing over 40 suppliers and a diverse portfolio of products, including HM Royal brand products, polymers, resins and diluents, films and wrapping tapes, adhesives, and other materials. We also have dedicated technical support in rubber to substrate bonding in the form of yours truly, and that extends to our customers offers of bond evaluations, failure analysis, product trial support, analytical testing, and a wealth of training materials on the topic. The first thing we're going to do is look more closely at the differences between a one and a two-coat application for a rubber to substrate bonding adhesive. For this example, we're going to take a look at preparing our ASTM D429 Method B 90-degree peel test that so many of you are familiar with. In these examples, left and right, we have two, we'll say metal substrates with a prepped and prepared bond area ready for adhesive. These materials will have been blasted or have a surface prep of any kind done. They'll be cleaned, they'll be ready for us to apply our adhesive and begin the bonding process. The first step in both of these cases is going to be our first coating. In the left example, we're coating our primer in order to get adhesion between our top coat and the metal substrate. In the right, we're going with a high performance OneCoat that already offers that compatibility with both polymer and metal. Then we go to everyone's favorite step and we watch some paint dry on the part. Following that, this is where we start to diverge in path. On the left, it's time to switch our equipment if we're spraying our adhesive or to mix, open, begin brushing a new material, or move to a second dip tank where we're applying our cover coat. It's important to remember that these materials are highly reactive with each other. That's why they're so good at being primers and cover coats in these systems. The downside to that is that contamination is a real issue. In the right example, we're ready to inject the rubber or compression mold it or transfer mold it. Or colander, or do whatever it is that we are going to do in our process to introduce the rubber to the adhesive. Next step, in the left example, we're moving on to coating our cover coat. In the right, we've already produced our finished component. There's really nothing else to do here in application. Now we're waiting for another lengthy dry cycle for our cover coat before finally we can introduce our rubber. So why do we show these side by sides? These are things that I think our customers largely understand, but we want to highlight the chief advantages of moving to a OneCoat system in terms of processing. And that includes reducing the complexity of the overall process, reducing the number of adhesives and solvents that are needed in the process, reducing the complexity of troubleshooting should we unfortunately see a failure as a result of the process. This will improve our line speed and reduce our time spent watching paint dry. And finally, there's no need for separate equipment for primer and cover coat, therefore reducing the amount of equipment we need in our plant. Earlier, we mentioned the limitations of common primers. And I want to say first that this is not simply limited to competitive primers, but to primers in general in the market. So what are these limitations? How do they impact our decision whether or not to employ these primers? And the first thing that we're going to focus in on is chlorine. In the common primers used on the market, be that something like a Thixon P11 from DuPont that HM Royal sells into various applications, or a competitive primer that's widely sold and commonly used, it's very common that a raw material ingredient is a chlorinated polymer material, often chlorinated natural rubber. So now that you know that fact, why does that matter? At elevated temperatures, let's say north of 280 degrees F, you're going to start to see the chlorinated rubber components degrade, and that's going to produce hydrochloric acid in the system. That sounds bad. The good news is these primers are formulated to include scavengers to reduce underbond corrosion and failures as a result of this production of acid. The bad news is that with time, the acid scavenger is used up, and these bonds over extended periods in exposure at these temperatures or in some fluid environments will still fail. So quick look at the chemistry. We're not going to dive into this deeply. Essentially, chlorine is freed in this system as a result of thermal degradation. As we continue to expose the system to heat, the acid scavenger, be it zinc, like in our formulas, or lead in some outdated formulas, is going to react it's going to react with this chlorine, and it's going to be used up. The zinc and the lead is going to combine with the chlorine, and it's no longer going to be free and available to scavenge acid. As a result, HCl is going to form and corrosion is going to occur at the metal surface. So what does this look like in the real world? Basically, we'd be looking at a failure to the metal or substrate surface that we're trying to bond to. In this case, we have metal components, and you'll see a lot of corrosion beneath the bond line as a result of exposure to elevated temperature with systems containing chlorinated rubber. On the left side, you see 100% failure to the metal substrate, which is inevitable over time. We have the cover coat and primer bonded to the rubber half of the component, but a failure to the metal surface. We can also see on the rubber half that the primer coating is intact. As these phenolic primers tend to turn a reddish brown color at curing, it's easy to identify the difference between the black cover coat and the red-brown primer coat. So let's look at some data. So here we have a competitive two-coat system versus a DuPont two-coat system, P6EF and Megum 5386. Both of these applications are the same, steel to EPDM bonding for an industrial roller application. Each of these systems was exposed for 6 weeks in a dry oven at 290 degrees F, and each of these is showing how well we retained rubber after this test by week. The DuPont primer in this case is one designed without chlorinated polymer component intended for long-term exposure at elevated temperature, and the results are clear. As we progress in time, we begin to see a little bit and then quite a lot of failure to the metal surface with the competitive primer. In this next example, we put a OneCoat system, high-performing OneCoat system, up against the same competitive primer. In this case, we're looking at HNBR to steel, again for an industrial roller, and we're still looking at rubber retention by week. In this example, we see the Megum OneCoat, which is free of chlorinated rubber, performs from week 1 to week 6, no variation performance, 100% rubber tearing bond, while the competitive primer falls apart at the metal almost immediately. A similar test, this is not in a dry condition, but in a wet environment. So what we've done here is we've taken a Megum OneCoat versus a competitive two-coat system. These are both nitrile to steel, and these results are still showing, excuse me, rubber retention by time, but this is in a boiling water test, which is an excellent test for showing long-term performance of adhesive systems. In this specific test, we see that while Megum does show some loss in performance over time at various temperatures, the results compared to the competitive primer are better. So why does this matter? The most important thing for us as distributors to do with our customers, whether we represent DuPont or we represent a competitor, is to know that our recommendations are backed by a wealth of test data and application experience. We don't at HM Royal make cookie cutter recommendations without clarifying information. We're not in the business of offsets. Primers, cover coats, and OneCoat systems that survive end-use environments are absolutely critical as our first recommendation. We don't want to learn through the process that our first recommendation was insufficient. Instead, we want to make sure that we understand the key aspects of your environment, and we generate comparative test data in-house from HM Royal to support our recommendation. So how do DuPont OneCoat systems perform in a varied array of tests? In this experiment, we have 8 nitriles and HNBRs with known formulas. We have 8 tests, including a baseline room temperature peel and immersion at various temperatures and times in various fluids. And we have finally 7 DuPont systems being tested, which include high performance OneCoats and TwoCoat systems. In this first example, we've kind of thrown it all together. What you see in the radar chart is all 7 DuPont bonding systems, all 8 tests, which you'll see at the points of the radar chart, and the line values fall at where the rubber retention values were recorded for these systems. And each of these lines represents the average performance across all of the elastomers. So in this chart, we see the various tests, and we see a wide array of different levels of performance based on what the system is, what the test is. In order to really understand this, we'll break this down a little bit more to more finite detail. In this chart, we have just 4 systems, the TwoCoat systems from DuPont. We have all 8 tests, and rubber retention is still the value that we're looking at. In this chart, you'll see that as we increase the temperature in water up to 270, 295, 320 F, that we really begin to separate the performance of these systems versus the top system. In this case, in all tests, we have a high performing system in Thixon P60F as a primer for Medium 5386. The other systems, however, perform pretty well in various tests at different temperatures, but their limitations are clear as we really push the limits of what these adhesives can do. Same scenario with the 3 top DuPont systems. So this is going to include a OneCoat application of Medium 15637, a double coat for high thickness application of Medium 3276, and a standard TwoCoat application of Thixon P60F with Medium 5386. We see all the tests around the radar chart, we see rubber retention in these tests, and we see average performance across all elastomers. What we see here is pretty interesting. So we start to see a degradation in performance of the OneCoat systems as we reach the very highest and most strenuous test in fluid, and that is 320 degrees F for 17 hours in superheated water in an autoclave. The Medium 15637, while it is a top performer in these types of environments, does show vulnerability at the very top end of our testing. Meanwhile, the P65386 non-chlorinated rubber containing primer does outperform our OneCoat systems in that very specific test. So what did we find? We found that many widely used primer technologies are a liability in environments where temperatures are sustained rather than instantaneous. We know that OneCoat bonding systems offer robust bond in addition to process simplification, troubleshooting simplification, and consolidation of adhesives, solvents, and equipment. The chief takeaway, I think, from this presentation is that for some environments, it is still important that we utilize high-performing, non-chlorinated rubber-containing primers in order to maintain suitability for the environment. Despite all this, we know that the OneCoat systems are highly effective in a varied number of applications in a varied number of environments. While the most strenuous tests may still show some degradation in performance out of the high-performing OneCoats from DuPont T&I, we know that in the vast majority of the tests, we had systems like Medium 15637 that performed very well. We know that these systems are good in a variety of applications. But again, we want to make sure that we're always recommending the best system. Sometimes the best system doesn't have to meet the most strenuous requirements based on the environment. But if it does, we need to be the most informed distributor with technical data generated by ourselves to support your application with your materials. HM Royal really has a unique supplier-distributor relationship with DuPont, and we have the materials experience to make us a reliable partner for elastomer bonding, releasing, and compounding. I want to thank you for taking the time to watch this webinar. This is a somewhat brief overview of some very complex topics, but this is a platform during these times when we can't meet face-to-face where we can offer some information, some valuable insight, and our continued support of our customer base. If you have questions regarding these materials, regarding any data that was shared here, or you'd like to reach out and have us perform testing with your materials in our laboratory in order to provide comprehensive data that we have the best system for your application, please feel free to reach out to me directly at my email on this slide or on my cell phone at any time. And please, if you'd like more information about HM Royal, even if it's not related to rubber to substrate bonding, feel free to reach out at info@hmroyal.com or via the toll-free number below, and we're happy to answer all of your questions.